Okay, I think we're about ready to start. Thank you, everybody, to come into this talk on Micronaut. We're going to do a deep dive into the motivations behind the technology and the design and so forth. For those of you who don't know who I am, my name is Graeme Rocher. I'm a creator of a couple of relatively popular Java frameworks that you may or may not have heard of already. Grails, which is quite a bit older than Micronaut, and of course Micronaut itself. I'm a principal engineer at a company called Object Computing, which can help you with all sorts of software requirements that you may have, whether it be Micronaut related or not. In 2018, I was fortunate enough to be awarded the Groundbreaker Award by Oracle for the work on Grails, and I'm also a Java champion. So that's me. So I'll be going through a little bit about the challenges facing Java in particular, not when it comes to developing lower footprint microservices. We'll do a introduction to Micronaut, look at Micronaut's way that it's trying to tackle some of these problems, and we'll do a whole bunch of demos. We've only got 45 minutes though, so we're going to have to rattle through this pretty quickly. So in terms of the challenges that facing Java, when you look at something like serverless or microservices, existing tools and frameworks for Java are not particularly optimized for cold starts and low memory footprint. And if you look at competing technologies, outside of the Java space, languages like Go, in the JavaScript world, Node, and so forth, they're actually, better in terms of cold starts. And you have fairly influential folks like Tim Bray and so forth not recommending Java from Amazon. Now, I think that's a bit of a stretch considering how prevalent and how extensive Amazon's Java customer base is. But nevertheless, it is true that Java is not particularly optimized for the cold start use case. And if you look at the problems that Java has when it comes to developing a framework on top of it. So when I talk about a framework, I talk about things like Jakarta EE, like Spring, and so forth. There's features like annotations, but the API is very limited. So there's nothing in the API that deals with meta annotations and so forth. Nothing that it deals with component scanning or anything like that. So it's difficult to build a framework that's based on annotations, just because the annotation API is pretty trivial. Type erasure as well. Generics were introduced much later in Java, so it's hard for frameworks to deal with that, because at runtime the actual instances have their types erased, and frameworks have to compensate for that. Reflection is very slow comparatively to direct method calls, and hard to optimize for the JIT. And the use of reflection leads to what I call this kind of explosion of reflective data caches. So reflection data caches are things like, if you think about Hibernate, it needs to read all your fields and all your entities reflectively, and then it produces a cache of all that reflection data. And then Spring will read all your beans reflective data and produce another cache of that data. And then Jackson, which you use for JSON, for example, or whatever Jackson toolkit you use, is going to reread your objects and create another reflection data cache. So there's no shared reflection data cache with all these tools that we use, and when you put together an application from all these different pieces, you end up with like a bazillion reflective data caches that consume a lot of memory. And then things like, traditional frameworks are typically built on being to be dynamic and based on dynamic class loading. So that can be a challenge. However, all of these problems related to Java, are greatly exaggerated. Java has been supposedly a dead technology forever. I've been working in the Java space for like 20 years, and first it was Ruby on Rails. Well, not first. Even before that, it was something else. But Ruby on Rails came along and was going to kill it. Node came along and was going to kill it. Now the trend is to talk about Go being the one that's going to kill Java, and it's nonsense. Java can be fast. You look at, for example, Android, which is based on Java, and Micronaut, which prove that it's how you build the frameworks and tools that we use rather than the runtime itself. And in terms of the server-side space, in terms of the way we build microservices, the way we build server-side applications, most existing tools out there are unfortunately based on these three concepts, which is the use of reflection to reflectively analyze your classes, the use of runtime proxies to create proxies to apply magic to your classes, whether it be transaction management or caching or whatever, and the use of runtime bytecode generation to compensate for the fact that you cannot create proxies from normal classes. You can only do it from interfaces, so they generate bytecode at runtime. And all of these three things lead to higher memory consumption. So why is reflection a problem, and why should you care about reflection? Luckily, unlike a few years ago, where we'd have to maybe guess what the problem is, the JDK today is open JDK, so you can just take a look. If you go to the JDK source file, this is the JDK 8 one, but it's the same behavior, nothing's changed, even in JDK 13. Basically, in that line on the class file, what happens is when you access any reflective data, whether it be a field, a method, a constructor, all reflective data is initialized for the entire class and held in soft references. So what does that mean? So for those of you not familiar with soft references mean that the reflective data will not be garbage collected until your application is running low on memory, right? So essentially, there's no way to be discriminate in Java. There's no way to say, Java, I want only the reflective data for this field, or I want the only reflective data for this constructor, or I only want the reflective data for this method. It's kind of an all or nothing deal, right? You get it all, and then it occupies memory, and that's it. You're stuck with it until maybe your GC comes along and you may get lucky and your application is running low on memory and maybe it gets garbage collected. But that's a highly unlikely scenario. So, friends don't let friends use reflection. Reflection usage increases memory usage. And using reflection is relatively slow compared to direct method invocation. And the problem is most modern server-side frameworks in Java are built on reflection. Even some of the specifications out there even mandate or enforce that the only way to operate with them is via reflection, which is unfortunate. So, in the Android world, they already kind of came across this realization quite a while ago, and solved the problem by using ahead-of-time compilation to pre-compute, or using annotation processes typically, the typical things that a Java server-side framework does, like dependency injection. So there's something called Google Dagger, which is at 2.1, which is the sequel or to Juice, the Juice dependency injector, and it's a dependency injection framework that primarily used in the Android world that doesn't use reflection and allows you to save on the memory console rather than paying the performance and memory cost of reflection. It does that computation at compilation time. So Micronaut took a lot of inspiration when we started designing Micronaut, which was probably 2.5 years ago. We started working on Micronaut. We took a lot of inspiration from how things are done in Android, and we thought about how can we take all of these concepts in Android and apply it to a server-side framework that gives you the same productivity and feel of something like Spring or Grails or whatever, and create something that has things like dependency injection, AOP, configuration management, bean introspection, and so on. But without the reflection and memory cost and performance implications that those entail. So with Micronaut, with Micronaut you can build obviously microservices, hence the name Micronaut. But it's not the only thing you can build. You can build serverless applications, i.e., we have support for AWS Lambda and functions and so forth. You can build message-driven applications that even don't have a HTTP endpoint. They just listen to message streams like Kafka or RabbitMQ message streams. You can build command line applications that are, just CLI apps. You can it even works on Android, so we made it a goal to be Android compatible, so you can use Micronaut in your Android apps. And pretty much anything that has a static void main works with Micronaut. So it's not just a microservices framework, it's a new way to build applications that tries to address this elephant in the room on the server side, which is the use of reflection. So like I said, so what is Micronaut really? It's an application framework for the future. It's reflection-free. It's runtime proxy-free. It doesn't use any dynamic class loading, so there's no hierarchy of URL class loaders and crazy OSGI class reloading at runtime or whatever. It's just a flat system class loader. There's no dynamic class loading problems that you need to debug. It uses AOT ahead-of-time compilation and also provides AOT APIs to do your own ahead-of-time compilation. So one example of that is our support for Swagger or OpenAPI, which generates the Swagger doc at compilation time, so that you don't have to have another tool at runtime that exists that analyzes your classes and occupies memory. Just generates a static Swagger.yaml file that doesn't occupy any memory. And yes, it does let you build microservices. So Micronaut is one of the technologies that is starting this trend, and there's a definite trend at the moment towards what I would say is more intelligent compilers and thinner runtimes, thinner, lighter, more memory-efficient runtimes. And this is a trend not just in Micronaut, but across the whole Java industry right now. So if you look at something like the design of Quarkus, for example, is taking that same path in terms of creating a more intelligent compiler that allows you to create a thinner runtime. And Micronaut is doing exactly the same thing, is creating a thinner runtime and a more intelligent compiler. And there exist other technologies out there. One of them is really interesting is GraalVM, which is a polyglot virtual machine, a new universal virtual machine from Oracle. And it has a whole bunch of features. It has a JIT. It has, that replaces the normal Java JIT. It has a language framework for building other languages called Truffle. A lot of it is production ready already. It does have one particular feature, which is the ability to compute using closed world static analysis, a Java application into a native machine image. You see, so you have this more intelligent compiler that computes your application by doing static analysis into a native image. So that part of GraalVM is actually not regarded as production ready yet. It's still experimental. It's called Substrate. It's very exciting because when you combine it with Micronaut, you end up with like startup time of 15 milliseconds and memory consumption of 14 megabyte for the process, which for Java developers is like, wow, this is like incredible. Micronaut's support for GraalVM Substrate is still regarded as experimental, just like Substrate itself. However, there's reason to be really excited about it, and there's also a reason why they work well together. So GraalVM requires you to declare upfront any reflection, any runtime proxies that you may use, any dynamic class loading that you may use, anything dynamic that you do, you have to declare it up front using configuration. And like I said before, because Micronaut doesn't have any dynamic class loading, doesn't have any reflection, doesn't have any runtime proxy creation, you don't have to configure anything, right? So if you stick to only using Micronaut parts, then you literally don't have to do anything. It just works with GraalVM native. Now, obviously, if you involve third-party libraries, whether it be something that's not necessarily GraalVM compatible, then you may have to configure something. But we're working towards getting more and more third-party libraries working with Micronaut, and in fact, that in the latest version of Micronaut, things like Hibernate work fine. We've also done things like, for example, with Jackson, we replaced the object marshalling in Jackson, the internals of it, to be reflection-free. So when you use Jackson to marshal JSON inside of Micronaut, it plugs in a module that allows you to marshal objects to JSON without using reflection. And all sorts of, we're doing all these things to optimize these third-party libraries that you may bring in to build a real-world application and making them better. But anyway, GraalVM Substrate is a technology to keep an eye on. So like I said, Micronaut has solutions for all of these different problems for frameworks that I mentioned before in the Java space. So in terms of a limited annotation API, Micronaut will actually pre-compute annotation metadata for each annotation on a controller or a bean or an introspection, and allows you to that allows you to introspect annotations without using reflection. And it will compute for you things like stereotypes and hierarchies, and so you can figure out if an annotation is annotated with another annotation. You can find all classes annotated with a particular type. It's like a way to query your annotations without actually reaching into the reflective part and spending all that memory. For type erasure, Micronaut will actually pre-compute type arguments, so that if you're writing like an AOP interceptor or something like that, and you want to get you want to know that this is a list of string, you just say get first argument type, and it will tell you that's a string. There's no having to go into there and trying to figure out using parameterized type or whatever, which complicates life greatly. For slow reflection, we eliminate reflection completely. For reflective data caches, there are no zero data caches in Micronaut, so that keeps memory really low. We do no class path scanning, and we do no dynamic class loading. So this all makes the whole runtime part of Micronaut so much simpler and easier to understand. The implications of this is already huge from a developer experience point of view. If you look at for example, just eliminating reflection, a Micronaut stack trace when something goes wrong in the AOP layer or part of the framework layer is so much shorter. You don't have this java.lang.reflect bazillion massive lines of stack trace that fill your whole screen, because there's no reflection to call or dynamic proxies to create those kind of massive stack traces. I'm just going to start with a demo then, which is initially to look at how something like the introspections work. So let's see how we can. So I have a Micronaut application here. Micronaut, very much like Spring Boot or something like that, or Grails, has an application class which has a static void.main. And you can run it, and the application starts up in under a second, which is what you expect. So what initially I'm going to demonstrate is bean introspection. So if I'm going to create a class here, let's call it pet, and it's going to have a name, and it's going to have an age, and we can just generate some getters and setters. So this is very typical kind of model class that you may marshal to JSON or whatever else. So historically in the Java world, what's happened when you at a framework level, when you want to read or write to this class, many frameworks would use something called the bean introspector, which is java.beans.introspector, right? So you would get a bean introspection, and it would get you the properties of the class, the getters and the setters, and you'd figure it out. And that's how many frameworks like Spring and so forth and Jakarta EE have worked historically. Now the problem with Inspector is it's yet another thing that maintains another reflective data cache, another one. Yeah. So and it uses reflection. So that's exactly what we wanted to avoid with Micronaut. So in Micronaut, instead of that, you declare this as @introspected, and Micronaut at compilation time will generate a bean introspection that is completely reflection-free and has allows you to access the property. So let's the class. Sorry. So let's have a look at that. So I'm going to create a Micronaut test. and it's going to be a JUnit 5 test. We're going to just have a test pet method for the moment. And what you can do is you can say bean introspection dot get introspection pet dot class, and we can get hold of an inspection. There it is. And then you can say introspection dot instantiate, and we have my pet. And then you can say introspection dot set property. Get required property to get a particular property. In this case, for example, name. So that's the name property, and you can say property dot set on the pet Fred, and then we can say assert equals, for example, Fred pet dot get name. Oops. So what this bean introspection is allowing me to do, and you can see that see how fast running tests is in Micronaut. This test is actually what Micronaut test does. It actually spins up your whole HTTP server and everything embedded, and the tests run instantaneously. So in this case, I'm working with the bean introspection API, and I'm able to instantiate pets, set properties, read and write properties, and so forth, and without using reflection, which is actually what we want to achieve. So this is like a fundamental building block of a framework, right? You need a way to do this, and that's what we're building the rest of the framework with. So a lot of the framework internals, Micronaut data, for example, which is supports JDBC to read and write objects using JDBC from the database using JDBC, uses this internally to instantiate objects, read, write, and everything being reflection-free and never having to feed information into GraalVM or consume memory. So it's also very common in Java where you have things like annotations, for example, validation constraints. So you might have like not blank here to declare that the name cannot be blank. And if you look at the specifications for things like this, the specification for JavaX.validation says that the annotation can either be on the field, in this case name, or it can be on the method, in this case the getter. Sorry. So the size has to be a minimum of 5 or something like that. So from a framework perspective, we immediately have a problem here. As a framework developer, we immediately have a problem because we have to now check whether the field exists, name. We also need to check if the associated method exists. The field is private, so we're going to have to break encapsulation and set accessible on the field and use reflection and get hold of that field so we can get that annotation on it. We're also going to have to somehow merge that data. Yeah, because there's an annotation on name and there's an annotation on the method. So we're going to have to somehow collapse that into a single view of the two things. Yeah. So this is the kind of problems when I was talking about annotation metadata and avoiding reflection and doing things in compile time rather than at runtime that we were trying to address with Micronaut. So with Micronaut, instead of that, what you can say is, on that name property, I'm going to get all of the annotation names by the stereotype constraint. Yeah, so that annotation names. So an annotation stereotype, if you look at not blank, both not blank is annotated with @constraint, and size is also annotated with .constraint. So this is what we refer to as an annotation stereotype, as an annotation on another annotation. So what I'm doing here is I'm saying, get me all the annotations with that are also annotated with constraint. And you can see that I can iterate over these, and we can just print them out for the moment. And if I run that, you'll see that I can actually get all that information, and it's merged together, and it's done at compilation time, and my runtime doesn't have to be complicated by having to introspect, cache, read the field, read the method, do all this crazy magic at runtime, because it's all happening at compilation time. Yeah, it's all happening, and the way that works is the compiler, which is a Micronaut, which is just an annotation processor for Java, plugs into your existing compilation, And what happens is at compilation time, we generate an additional set of classes, in this case pet, that sit alongside. So all these ones that start with $, and they're compiled with Micronaut and marked as synthetic. We never modify your own bytecode. We never touch the bytecode that you generate. We generate an additional set of classes that sit alongside your classes in the same package, so we don't break encapsulation or anything, or module systems or nothing. And they sit alongside your classes, and they provide that metadata that we need to perform the kind of frameworky things that we need to do in Micronaut. So that's been introspection. Yeah. Yes, validation doesn't work, but our validation implementation is completely based on this. But we do have a way to, in Micronaut, you can map the value of one annotation to a value of any other annotation. So for example, what we do is for @entity, which is typical, java_x.persistence.entity, we say that whenever you add entity, we also add @introspected. So you don't have to be repeating, @introspected all over the place. You just put @entity, and we know that's typically going to be an introspected. We do the same thing in many use cases. You can map, and that's actually an amazing feature of Micronaut, that you can map the value of one annotation to another annotation, because I'm not sure if you guys are aware, but they decided, the Jakarta EE folks and the Oracle folks decided to do the Big Bang rename from java_x dot blah 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 to Jakarta dot blah blah blah. So with Micronaut, that problem is really simple, because all we say is, I'm going to map all the Jakarta annotations onto java_x, and we treat both annotations exactly the same. So for Micronaut, you guys are safe. You don't have to do anything. It's all going to be handled at compilation time, and there's not going to even be an upgrade problem. Introspected, yeah. AOT reflection-free replacement for being introspective. You can set key properties. You get all annotation metadata. Annotation metadata lets you compute annotations and stereotypes, and without using a reflection. And why do we care about annotation metadata? This is what I was talking about, mapping annotations. How many freaking nullable annotations are there out there? It blows my. You got java_x.annotation.nullable. You got the one that Kotlin uses, which is org.jetbrains annotation.nullable. You got spot bugs or find bugs version, which is another nullable. There's another one in Spring, because they just said, okay, we know another one, because we don't have enough. Let's just add another one. So you got all these freaking nullable, and with Micronaut, all we do is say, just map them all onto java.x.annotation.nullable and be done with it. So it doesn't matter in Micronaut what nullable annotation you choose. It's going to behave exactly the same. And the cool thing is that it doesn't alter the runtime characteristics, because we don't have to check, is this version of nullable used, is that version of nullable used, is that version, we just map them all into a single value, and in the runtime there's only one check, which is just really good. So yeah, you can get hold of, like, if I had a list of string, you can get hold of the generic type arguments, and it just works. So why should we care? Why should we? This whole thing of providing compile time computation of generic type arguments. I know that's a list of string. Why do I have to jump through loops to do it? If you think resolving generic types in Java is easy, I recommend you take a look at this class in the Spring code base. It's called Resolvable type. In fact, I'm going to copy it into my browser, and we can take a look at it. So this is the class in Spring that deals with resolving generic type arguments in Spring Framework. It's called org.springframework called a resolvable type. And it is, hold on, I'm going to keep going down. And then keep going. Oh yeah, yes, we're at the bottom. 1,673 lines long to deal with the fact that type erasure happens in the JVM. That's the consequence of type erasure for framework developers. And kudos to the Spring folks for making it as good as it can be. So Micronaut dependency injection. So again, dependency injection in Micronaut is completely reflection free. We can do a quick demo of that. We're gonna have to get moving. So I can create like a. Oops, that's the wrong one. So yeah. Okay, so I can create like a, pet service, new class here. That's a pet service, and it's going to be. You can define it as a singleton, but it's using a singleton. Maybe we'll just return a list of pets, and something along those lines. And you turn arrays as list, new pet, something like that. Maybe we just create a constructor here because it's going to be easier. And Fred is 15, and whoops, new pet. Bob is 12, and oops, shouldn't put that there. So that's my bean. Then we come in here and we create a pet controller, and this is going to be my controller, and we're going to have a bunch of pets, and this is going to be like a list of pets. We're going to have an index, and we're just going to map to the root URI, and we're going to have we definitely prefer constructor injection in Micronaut. Very, very recommended to use constructor injection. New pet service. Let's list all those pets. And then how do we test that? So we can create a pet client, which is going to be an interface, and it's going to be a client for my pets endpoint. Can get hold of a list of pets, such as at the index. So list of pet list. And that's an interface. We can inject that client into my test. Like so, and we can test, oops, list pets, and we can say assert equals, and if the demo guards are with me, we might be able to make this test pass, like so, and we run that. Hopefully the demo guards are with me. Yes, it passes. So that is a little brief, rapid demo of using Micronaut and dependency injection. So I've created a pet service. That's a singleton. I've injected into the controller using constructor injection. I've written an HTTP client, which is annotated with @client, which is an interface, which is automatically implemented for you at compilation time. If you don't believe me that this is a real HTTP request going on here, we can go into my logback configuration and say logger name equals io.micronaut.http.client, and we can say level equals trace, and we can rerun that, and you'll see that what we actually have is the traces from my HTTP client making the request and the JSON coming in and back. And notice how that my tests are executing instantaneously. There's no waiting for containers to start up or slow startup time. It's just fast. So that's Microsoft dependency injection. Each class that you define is represented by a bean definition. It wires together your application without reflection. We support constructor injection factories. Micronaut is actually compliant with the Java X.inject spec and TCK. We support configuration properties, so you can say, add configuration properties on the bean and have them bound to your application.yaml or your environment or application.properties or whatever it may be. We support conditional beans, so you can say another bean requires the presence of another bean or the absence of another bean or a particular property to be set, to be active. We support in the Notion. There's an annotation stereotype called @executable, which if you look at the annotation stereotype hierarchy for my controller here, you'll see that the get annotation, which is an annotation, is annotated with HTTP method mapping, which is annotated by executable. It's a stereotype annotation that we use. And what that means is that it'll create, whenever executable is found, it creates a compile time handle to invoke your method from the framework without using reflection, which is really nice. So whenever Micronaut invokes your code from the framework, it's always reflection free. You can also detect the presence of, on startup by writing what's called an executable method processor. So this is how scheduled tasks work in Micronaut. We have a processor that listens for the definition of @scheduled on any method, and this runs at startup because we index every definition of @scheduled so that it doesn't impact startup. So we don't have to go searching through your code base looking for instances of @scheduled. Using component scanning and these things that are slow. AOP is so cool in Micronaut. It's really one of my favorite features. Let's take a look at, for example, I want to create like a not null interceptor here, just because I want to, and I'm going to save time. I'm going to copy some of these guys over here, and I'm going to make this targeted at a method. And I'm going to annotate it with this is at around device. So I'm going to decorate existing behavior. And then I'm going to create a not null interceptor. And this is going to be an @singleton. And it's going to implement method interceptor. So that's going to be my method interceptor. And it's going to implement the intercept method. And for the moment, we're just going to proceed with the original invocation. And then in my not null interface, I'm going to say that this references the not null interceptor. So this, whenever this is added to anything, we're going to invoke not null. And then in my pet service, we can say @not null on that method. Or maybe we create another method called save pet string name or something like that. And it doesn't matter for the moment. We're just going to output the name, and this is going to be @not null. And what you can do is in here you can say iterate.context.get parameter values. Maybe actually want to iterate over an array so we can get the index. Get context.get parameter values. Parameter value, if parameter value equals null, throw new illegal argument exception, parameter @index I cannot be null, something along those lines. And now if we go back to my test, if I were to try and call, and let's inject my pet service here, if I were to try and call pet service.save pet with null, and run the same test, what's going to happen is it's going to fail with parameter @index cannot be null. So this is what I was talking to you about earlier, is I've just written an AOP interceptor that intercepts my save pet invocation every time @null is present. And you can see, look at that stack trace. You know, it's literally the JUnit stack trace which is JUnit uses reflection, is ridiculous. It's like all 31 frames, and then Micronaut, it's got 3 frames of stack until the actual until the actual interceptor. And if I put a breakpoint here, if I knew how to put a breakpoint in presentation mode. Why can't I add a breakpoint in presentation mode? Okay, there we go. So if I put a breakpoint there, and I actually put for something like valid, like Fred or whatever, the distance between Micronaut and actually invoking your code is minimal, you know, compared to, if you were using reflection, the stack trace would be like 10 times the size. So everything is very optimized, and that makes the JITs work a lot easier. You know, because the shorter the stack distance, the JIT is able to inline your code a lot better. So really important things at play. So add around intercepts any method, and you can add method interceptors. No runtime proxies, no reflection needed, no bytecode generation, no my fancy proxy factory bean, you know, complexity in there. Really simple to do, really simple to implement. And I'm kind of run out of time for this last demo, but I was going to do a quick demo of Graal VM computation into a native image. Let's see if I can actually I'll get the thing going, and we'll see if demo is boxed. But basically, the way you build a native image is you assemble it. You assemble the jar file, and then you run the native image command, and you run native image and just point it to your jar file, and it will build a native image, and it will execute in. First of all, I have to do executable list Java and make sure I'm using the latest version of Graal VM. Use Java, so I'm going to use the latest version of Graal VM, and then you do native image. Let's make it bigger so you can actually see what's going on. Typically add no server, but that's not necessarily necessary. You just say build a slibs, and it will build my native image, and this application will work the same. Oops, it wouldn't build my native image if I had chosen the, anyway, doesn't matter. Chosen the native image feature when I created the app. But basically, there's a feature when you create an app where you can say mn create app, because we still regard it as experimental Graal VM. You have to create an app called foo, and you say features Graal native image, and that will generate an additional file which goes in source main resources metainf, which just specifies the name of your main method, your main class. I could probably add it, but I don't have time for that because the presentation is coming to an end. But essentially, with Substrate, if you want to see Graal VM actually with Micronaut, I'm doing a bite-sized talk at 1 o'clock with Micronaut data, so I'll definitely demo it at that point when I have a little bit more time. It's coming to the end of my talk. So Micronaut startup, we've seen big improvements in JDK 13. It was actually great at Oracle Code 1 in San Francisco to see the Java team at Oracle demoing Micronaut to show startup improvements in JDK 13, which are significant. So goes down to 750 milliseconds on relatively antiquated hardware like this guy. And if you use class data sharing, which is a really nice feature as well, goes down to 400 millisecond startup time. And then, of course, Graal VM Substrate, you know, if you want the ultimate startup time experience, whether if you're doing serverless, but obviously still experimental, that's the direction we're heading here. But the point is, you know, we're heading towards a new generation of frameworks, and Micronaut is one of them that provides a nice set of framework primitives, like I would like to call them building blocks for building applications that don't, when you finish building your app and you're going to production, you don't end up with this suck of memory consumption and startup time and problematic behavior, because the base primitives that you build with Micronaut are designed to never get to the point of taking 3 or 4 minutes to start up, or, you know, which historically been the case. We do that by sacrificing compilation speed to gain a lot more. So there is a compile time overhead. Yes, there is. But it's not something significant that you should worry about. We solve problems in existing frameworks like Spring, Jakarta, and Java in general. And it opens the door to a future when Graal VM Substrate, native image, etc. becomes mature and out of the experimental phase, where you could take your app and, you know, go fully native and just make it happen. So if you want to hear more about another project, I'm doing a bite-sized talk at 1 p.m. on Micronaut data. So please do come. In the meantime, I have time for questions, and I also have some Micronaut t-shirts to give away. So we'll do a throw into the audience exercise. And I also have these awesome Micronaut stickers to give away. So do come and get your stickers, because you want one of these on your laptop or your friends' laptops. In fact, I have loads. So do come. So yeah, any questions? Yeah. So we support Lombok. Sorry, the question is, how does Micronaut deal with Lombok? So we support Lombok. Micronaut is an annotation processor, and Lombok is also an annotation processor. So the trick to get them to be friends is the Lombok processor has to be declared in your build before Micronaut, because Lombok mutates your AST. So Micronaut has to see those mutations. It has to see those changes. So you have to declare Lombok before Micronaut. If you're not doing that, then things will go wrong. You have to always have it before, the first in the list of your annotation processes. So yeah, we do support it though. Any other questions? Yeah. Yes. Yes, so we support Kafka and RabbitMQ for messaging, and then for eventing we support in-memory events. So you can publish events and listen to for events. And with Micronaut data, we just actually released support for like transactional events. So you can listen for event only if a transaction commits and that kind of stuff. So yeah, we do have eventing support. Yeah. So as the question is it possible to implement your own bindings? Yes, Micronaut is a framework set of primitives. You can build whatever you want. The world is your oyster. And we have more plans to support more types of eventing systems and so forth. But like contributions from the community would be awesome. And the contributions we've already had have been massive. Like Micronaut has only been open source for a year. We're already up to nearly 3,000 stars on GitHub. We've had so many external contributors already who contributed key things like Pico CLI support. It's really been quite staggering. One of the things we've been taken back with is how much external contribution and enthusiasm. It's been awesome. So I think we're out of time. But I am going to throw if you don't mind, just throw some t-shirts into the audience. So we'll see how this goes. See how that... oh, shit. No, that's... Maybe I'm going to drop down and try and get one at the back. Okay. And if you do want stickers, please come to me. Thank you.